Use the second derivative test to find the relative extrema for plot A. Hey, that looks familiar. I hope so. So we have two steps which are sort of hidden in the directions here. The first step is to figure out the values that make the first derivative 0. So for part A, we have to first find the first derivative, which we already did, 3x squared plus 10x plus 8. And then we have to factor this because we have to see where it equals 0. So for the second derivative test, you don't do the when does it not exist portion. You just do the equals 0 portion. How does 3x squared plus 10x plus 8 factor? 3x plus 4, x plus 2. We can't have any negatives because all the signs are positives. So what does the first factor say about x? Negative 4/3. And the second factor? Negative 2 in Yano vision. Very good. All right, so that satisfies this part. Let f prime of c equal 0. So now let's do what is the second derivative? What is the second derivative? 6x plus 10. So now you just plug in the numbers that make the first derivative 0 into the second derivative. So we'll do f double prime of negative 4/3. We do not care what the value is. We only care about its sign. So 6 times negative 4/3 plus 10 is. So at negative 4/3, since the second derivative is positive, that means our point is a convenience. I erased that portion of the show. Well, think about it. If the second derivative is positive, that means it's concave up. So if it's concave up, then this point is a relative min. So we have a relative min at negative 4/3. We'll find the y-coordinate in a second. And now we stick in negative 2. So 6 times negative 2 plus 10 is negative. So since it's negative, that means the function is concave down around it, which means it's a relative max. So now we just put a negative 4/3 and negative 2 back into the original function to get the y-coordinates. So if you would, please put a negative 2 and negative 4/3 into the original function. At negative 2, I got negative 10. And at negative 4/3, I got negative 274 over 27. Part B is a lot nicer, so we'll move a little bit faster. G of x is x squared plus 5x plus 6. Let's first find the first derivative, which is we're going to find where the first derivative is 0. So if you set 2x plus 5 equal to 0, what do you get for x? We'll now find the second derivative. What is the second derivative? 2. Don't be scared. Stick in negative 5/2 in for x. What do you get? 2. So g double prime equals 2 means no matter what you stick in for x, you're always going to get 2. So when we stick in negative 5/2, we get 2, and 2 is positive, which means negative 5/2 is a relative min. And negative 5/2 comma, put in negative 5/2 back into the original function. $99. Yes? Yep. I love to give wrong answers. Mike, I was trying to study from your video, and I got a different number, but I didn't correct you in class because I didn't do it myself. Yep. You'll hear that in 2 weeks. Fun fact, what type of function is this? Quadratic. So remember, quadratics are of the form ax squared plus bx plus c. Remember that guy? What's the derivative of ax squared plus bx plus c? Say it one more time, please. Two ax plus b. And if we set 2ax plus b equal to 0 to solve for x, what do we get? Negative b over 2a. Where have you seen this negative b over 2a concerning a parabola? It's the x-coordinate of the vertex. So that's where that came from. Hooray! We just proved something from college algebra. Yay. And it's either going to be a maximum or a minimum, depending on if it's concave up or concave down. And A tells you that part. You are welcome. Part C. Another portion of you are welcome. We actually don't need that much room for part C. If you want to rewrite it as x to the negative 1 like we did before, go to town. Oops. So that's x to the negative 1. So what's h prime of x? So that's negative 1 over x squared. So when does the first derivative equal 0? Huh? Never. So we can't even use this test. It is actually going to turn out there won't be any relative extrema. So even if you use the first derivative test, you wouldn't have anything. But as far as the second derivative test is concerned, it's inconclusive. So we go right to 3. Well, remember, we're only considering the case where it equals 0. There is a value where it doesn't exist. So there's issues there. But we don't want to generalize for all rational functions, because some rational functions will have relative extrema. But this one does not.